Mr. Anderson, when I said it.
Hey, check this out. So on a given day, the flow rate F is given by that equation. What speed will maximize the flow rate? So again, like we talked about, if I'm going to try to maximize flow rate, which is represented by the letter F, I have to set F prime equal to 0. So I need to find F prime first. F prime is a quotient. F is a quotient, so we got to use a quotient rule. So it's going to be low, should be 22 plus 0.02 v squared. D high, which D high would just be what? 1. That's good. Minus low. Low D high minus high. D low. And D low would be 0.04 v. All divided by the square of what's below. Make sense? Okay, so as far as this not existing, this down here would need to be 0. And the truth is that could never be 0 because 22 is positive, 0.02 is positive, and v squared, regardless of input, will not be negative, right? So there's no way that the denominator could be 0. So I'm only concerned about where is this equal to 0. And we were talking about how to do this on the calculator, like by graphing. But what I'm thinking is we might be able to do this without doing that, simply by recognizing that the only part of a fraction that can make the whole fraction 0 is the numerator, the top. Yeah. So I'm just going to say 22 plus 0.02 v squared minus 0.04 v squared equals 0. I'll just set that numerator equal to 0. This gives me 22 minus 0.02 v squared when I add these two like terms here and here.
Wait, what happened to the minus v?
I multiplied the v times the v and got v squared. And then add over 22. 22 is equal to positive 0.02 v squared. And then it's a question of division and then square rooting. And it's like 33 something, right? 166 equals v. Okay. Yeah, and that would be measured in what kind of units? Yep, it'd be a miles per hour unit.
Justify that, would you have to go...
Let's talk about that. So, first of all, before we justify anything, are you guys okay with that number? And I don't know, we need to still investigate.
I got it.
You figured it out?
Yeah, I think we shouldn't go over enough once the other side enough.
Okay, fair enough. You guys are okay? All right. So then Anna asked a good question, and I want you guys to make a judgment on this too. Up here I wrote to find the relative min or max of f, set f prime equal to 0 or dne. Then use the blank or blank. What would go in those two blanks over there? First derivative test, second derivative test. So I've got that choice here. What do you think would be the easier of those two choices? Why? Already have it. Second derivative is going to be a little bit of a pain. Agreed. It's going to involve another quotient rule, maybe a chain rule, depending on how you handle that. I mean, it's going to be pretty labor intensive. And like you said, we already have the first derivative. And in fact, if you graphed it, you already have it graphed in front of you. But let's say you didn't have it graphed. This is where Anna was kind of going, like, what do I have to show?
Would I have to show that it changes from...
It?
That f prime changes from positive to negative.
So let's do that. So let's go f prime of some test value and f prime of another test value. What test values would you guys pick?
30 and 35.
30 and 35 makes sense. They surround the 33 number that we came up with, and so I think that will give us the information we need. So Audrey, what'd you come up with for f prime of 30?
-4.
-4, okay. What about 35?
2.5.
2.5, okay. So we can see... Ooh, that's interesting. That's kind of the opposite of what I expected to see, right?
But when I plug it in...
There could be a numerical issue here.
Yeah.
Because we're trying to maximize flow rate, and doesn't the data right there indicate a minimize?
Yeah.
A minimum, right? Because f prime went from negative to positive. Will you guys double check her numbers? Because her strategy is good. So you're getting 0.0025 for the first one. Okay, let's just double check that. And then what about 35? What'd you get for that?
-0.00115.
Yeah, for 30 I got 0.0.
Okay, so negative number, small but negative nonetheless. That's the pattern we were looking for. So, so honestly, like here's something, like if I ever asked a question this way and I said, hey, what speed will maximize the flow rate? And you only got one critical number and it seems like there's a minimum at that critical number. One of two things happened. Either I wrote a confusing question or you've made a mistake. One of those two things is true. In this case, maybe there was a little arithmetic error or something.
Yeah.
I liked what Marguerite did. She had her equations already in the calculator, and she just did y1 of 30 and y1 of 35 instead of trying to plug in all those numbers. I can see how, hey, I should be perfect at this because I've done this for a long time. I can see myself making the same mistake you did with all those parentheses everywhere. I mean, it's kind of confusing. So if you handle it that way, you let the calculator handle all those confusing things. It's better. So I'm guessing she put f prime in as her y1.
Put it in, and then you can
Oh,
select quit.
There's the alpha trace thing.
Yeah.
Alpha trace, parentheses, just, go parentheses 30, parentheses 35, whatever you want to evaluate at, and it'll do all that evaluation for you, which I find very convenient.
Or you can, I store it as X, whatever I'm plugging in.
There you go, or A, B, C, D. You can store it however you want. Yep, exactly right. Yep, that simplifies it quite a bit too.
So then for writing it out, could you say f has a relative maximum when v equals 33.166 because on the left f prime of 30 is positive and on the right f prime of 35 is negative?
Sure,
Does that work? Okay.
well said. Yep, I'll write that out up here too. So we'll say f has a relative max.
Did you say it's optimized, or did you want us to say?
Let's be specific because optimized could be a minimum.
Okay.
So maximized, maxed, has a relative max. Yeah. Because if you want to put this in here, we already said this, so you don't really have to do this, but you could say that. And f prime changes, you can use delta, changes from positive to negative at that particular speed, or around that particular
You
speed.
don't need to put those in your explanation, re-say like f prime of 30.
Yeah, I think this is nice because it shows like a complete argument, but we already proved that right over here
Okay.
with all this stuff. The hard part is make sure that you do include something like that if you're just pulling your number off of a graph. Because if you're just pulling your numbers off of a graph, you never had to do any of this stuff. You absolutely have to say this somewhere in your argument.
Yeah, I meant the f prime of 30 and f prime of 35.
You gotta have that.
Write that in your justification.
Well, if the calculator's active, you could have used a graph. I mean, that's where there's some debatability there.
Okay.
And it probably
Just have
wouldn't,
it down somewhere.
it probably wouldn't be a super well-formed question for that. Like if it were a quiz or a test question, I'd have to like rephrase it if I wanted to see that. Show evidence for your reasoning or something like that. I have to put that in there. Santi?
See, like the subject stable number every square root in time, do you have to have that if it's not the active?
No, yeah, you could, I think your point is well taken. I mean, you really could jump from here to there. And this gets at your question kind of earlier, like, don't you have to show some steps? You really could follow that red arrowed path there, as long as you show that you set f prime equal to 0, and they came up with the right critical number. All these steps right here in the middle, I don't know. Maybe you did them, maybe the calculator did them. It doesn't matter. So, yeah. Great questions. Anybody else? All right. Well, then let's do number 4. And I like number 4. Flip over there, please. Number 4 is about a farmer. Okay. So like with any of these story questions, as always, let's just please read this as a story and see what we can figure out about this later on. Farmer plans to fence a rectangular pasture adjacent to a river. The pasture must contain 245,000 square meters in order to provide enough grass for the herd. What dimensions will require the least amount of fencing if no fencing is needed along the river? So in just a handful of words, can anybody describe what this is about? Be contextual, though. Okay, because what is the farmer doing?
To have a pasture big enough for
To feed his cows.
Yeah, he's trying to feed the cows with this pasture. What shape does the pasture have to be?
Rectangular.
For some reason, it's got to be rectangular. What is another key feature in this whole story?
Square meters.
Square meters.
You don't have to fence it.
What is a...
By the river, you don't need.
That's to me a key feature. The fact that there's a river that's one of the boundaries. Apparently cows don't like to wade through water. Maybe, I don't know. And so he does not have to put a fence up along the river. So for the first time with these, I am going to draw a picture. So please feel free to draw your own picture. There's my river. Here is my pasture. A couple of lonely cows out there. Got a black and white one.
This is amazing.
It does sort of look like a panda. Here, let's give him some more black dots so it doesn't quite look like a panda. There's a cow and a panda. Okay, so there's my black and white cow. There's my brown. You know, when you can like zoom in color and then zoom back out, it really helps. Okay. I know. I did my best. So then let's draw on the fence too. Here is one side. There's another side. There's the last side. So it'd be really important to recognize that there's no fencing needed along the river. So it is a rectangular shape, but there's no like top part to the rectangle covered by the fencing. Yes, ma'am.
Since it's gonna be a rectangle, and that means like that, like the
Can I just call it like X side and the Y side the Y sides and X sides don't have to necessarily be equal to each other?
They do. Well, like,
It's a rectangle.
yeah, if it's a rectangle, yeah, the vertical and the horizontal don't have to be equal.
So do we just get to say that like one side, like Y, if Y is longer than X, then that should be against the river, so like when you're running?
Well, so it would really, like, our reasoning would really depend on our setup and our picture.
Because like, so if you're gonna,
Like,
the
if we're,
perimeter of that, would that be
Well-
2Y plus X?
well, let's talk about that. So, are you guys okay with this? If we put a Y and an X right there, like Y up and down makes sense to me. X left and right, that makes sense to you.
Yeah.
Is that okay? So then, Anna, in the end, we're going to say that, hey, Y should be this and X should be that. But in order for us to match which side is actually parallel to the river and which side is perpendicular to the river, we do need a picture, like kind of a setup to say, oh, X should be this side, Y should be that side, and we can connect our numbers with the appropriate dimensions. Does that make sense? You could set it up however you want. You could call them L's and W's for lengths and widths, Y's and X's, X's and Y's, whatever. I like this. I think this makes a lot of sense. Okay, so basically all we've done here so far is we've read this like it's a story, and we've drawn a picture of the story, right? There's a pasture and a fence and some cows along the river. So now let's start picking out some important math stuff. Let's start by trying to figure out what is it that we are trying to find in the end. What's our objective? Find the X and Y value. Yep, what dimensions? And what are we trying to do with those dimensions? The least amount of fencing. So when you see words like least amount of fencing, what are we trying to do? Minimize perimeter. I like that word perimeter there. This is not strictly a perimeter because perimeter means the distance around, usually a closed figure. But I like the notion of perimeter because we are like measuring the distance around just the fenced part, right? Trying to minimize perimeter. So to go along with the statement that I've written up on the board there, to find the relative min or max of blank, you need to set blank prime equal to 0 or DNE. Guys, we need to figure out an equation for perimeter, don't we? So what would that equation be? There we go. 2y plus x or x plus 2y, same thing. So that is absolutely lovely, but unfortunately, it gets a little bit less lovely for a second here because if I was looking at this and I thought, sweet, there's my perimeter equation, I just need to find p prime. So I'm going to go, all right, p prime equals, here's where I run into issues. Is this going to be p prime in terms of y or p prime in terms of x? And this is where we're going to have to do a little substituting before we find p prime. What is the other piece of information in here that's going to be useful that we haven't used yet?
X times Y equals 245,000.
That is well said. We need to use the concept of area to help us, and we are told that the area has to be 245,000 square meters. So we can use that purple equation to substitute into our green equation to help us get what we want. So, would you guys suggest on the purple equation, would you guys suggest solving for x or solving for y? I think solving for x will create a little bit of an easier situation, so I like that idea. So over here I'll say x equals 245,000 over y, or would you guys be okay if I wrote this instead? Y to the minus 1. That'll flow a little smoother into what we want to do on the next step. If you wrote over y, that's fine. I kind of like this better just because it'll flow better. So p equals 2y plus, instead of an x, I can write 245,000 y to the negative 1. Again, I want to make sure you understand why. The reason why we did that is because up here, p was in terms of y and x. Unless you are in Calculus 3, that's an issue. If you're in Calculus 3, you'll learn a way to deal with that. We have not learned that, so let's not stress about that right now. We'll just use a little substitution to get around that. Once I've gotten here, now we can really use that statement to find the relative min or max of blank, set blank prime equal to 0. Let's find p prime. P prime equals y to the what? 245,000 y to the negative 2. So we need to set that. No, actually, I take that back. I was about to set it equal to 0. I want to talk about one thing. Are there any values of y that would make the whole p prime not exist? 0, right? Because y to the minus 2 is the denominator. Why would we not even consider that as a realistic option?
Because you can't have 0, like it would make the area 0.
Yeah.
There would be no.
If y is 0, how many cows are you going to fit in your pasture? None, right? There's no pasture to be in. Okay, so we're going to ignore the DNE, right? So we'll say equals 0. And this is where sometimes we get to this spot and we say, sweet, the only thing left is, you ready? Just algebra. That may or may not be an apropos statement. Does anybody have any suggestions on how we could solve that? Beyond graphing.
If you put 245, 100,000.
Okay, so the y? So 2 minus 245,000 over y squared?
Yeah, then you can solve for it.
Okay, now what?
Then you add that over and then multiply y squared. So you get 2y squared.
Okay. I like it. So you could multiply the y squared over. That's going to give us 2y squared equals 245,000. And now that that y squared is out of the denominator, this feels like way more familiar, right? You divide by 2, you square root, and this comes out pretty nice, doesn't it? 250?
I got
350. So you guys get 350? Yeah. All right. So the y dimension is 350 meters. Yeah. And then you plug back in to find the x. You know that x equals 245,000 over that. X equals 700 meters. Okay. Now, we haven't justified our answer yet. We need to talk about that really quick. But first, your question?
Is for p prime, is it 2 plus 245?
It is. But then when you do your derivative, your power rule says that this has to come down in front.
Oh, yeah, okay.
Yes, ma'am?
So technically, like if you would have drawn the longer side being y,
Yep.
would you have gotten your answer flipped?
It would have been flipped,
And
which
would both
still
be
give you the
correct.
same dimensions. It would match up with your picture correctly. Yep. Okay, so we haven't justified it. I know it didn't say to justify, but we'll always practice that just to make sure that we're doing our best. My question to you is a pretty simple one. We did the whole first sentence up there, then use the first derivative test or the second derivative test. In your opinion, what do you think would be better? Any ideas? What do you think, Maddie?
I just had a question.
Okay.
When you're writing the problem at first, does it matter if you did if you switch the x and the y?
So let's talk about that. Like that's kind of what Anna was going for. On a quiz or a test, I'm going to try to scaffold it in such a way that that's not an issue.
Okay.
But even if I didn't do that, like if you had a picture that went along with that and said, hey, X stands for this, or even if you didn't have a picture, you just said X stands for this and Y stands for that, it really wouldn't matter which one you picked.
Okay.
Because if your Y's and X got switched, then your Y's and X would get switched. And like the right dimension would go with the right number. But I'll try to scaffold it in such a way that that doesn't become something. And that's like honestly mostly selfish because I don't want to like go back through and be like, what do they mean by X again? Oh no, okay, it was different than her and it was different than him. And that's just so that it's easier for me to grade.
So would you write your answer like that, or would you write the dimensions as like 350 meters by 7?
You could just list it out like this. This is no big deal. Hey, are you guys okay with this statement? I think the second derivative test would be easier here. Let me explain why. Here's my first derivative right here. That's my first derivative in that green box. Do you see how finding p double prime really wouldn't be that hard?
No, it wouldn't be.
So if I said, all right, well then p double prime equals, well, the derivative of 2 is just 0. Then it would be positive, because a negative times a negative is a positive, 490,000 y to the negative 3. Well, gosh, all I would have to do is take that 350 and plug it in there. P double prime of 350 would just be 490,000 over 350 cubed. I have absolutely no idea what that is. Santi, do you know?
Oh, what?
490,000. You just like plug some numbers in there. Well, you know what I could do? I really could do this completely without the calculator at this point. I could just say, that's positive, right? I don't know exactly what that number is, but I am for certain that it's a positive number. And here we go. If p double prime is positive there, then p is blank. P double prime is positive. P is?
It's concave down, or
Concave up. It's the creepy clown face, right? If p
Oh.
double prime is positive, p is concave up. Therefore, p has a relative minimum at whatever that was, y equals 350. So there's your justification practice. You could absolutely use p prime. I think p double prime is a little faster here. Okay, any questions? Only 2 cows. Get lots of grass to eat.
Looks like a cow and a monkey. I mean a panda.
Cow and a panda. Cow and like a sort of a weird panda. Okay. So our last example is Back to the Future. It's a water tank. I think there's a water tank in Back to the Future at some point. Yeah, I'm sure there is. All right. So I hope that as you read this over, this looks extremely familiar because all the details about this question are exactly the same as a previous question, but then the thing you're supposed to do with it is a little bit different. I'll read it out loud to you. You guys feel free to read along with. It says the amount of water in a storage tank in gallons is modeled by a continuous function on the time interval 0 to 7. T is measured in hours. In this model, rates are given as follows. The rate at which water enters the tank is f of t. And it's a modified trig graph measured in gallons per hour. And B, the rate at which water leaves the tank is g of t, which is piecewise measured in gallons per hour. So on the graph down there, can you guys identify f of t and g of t real quick? Which one is f of t? The curvy one. Yep, there you go. So f of t, I'll just label it right here. And that means g of t is the piecewise linear. All right. So then we read the objective, the bullet point there. So on the open interval 0 to 7, at what time t is the amount of water in the tank the greatest? At what time t is the amount of water the greatest. What on earth is that talking about?
The space between the lines on the graph.
Well, now you're getting a little bit too technical for me. I just am wondering, like, when it says, what time is the amount of water in the tank the greatest? How would you interpret that? Like, you're starting to tell me procedure, Anna. Like, hey, let's do this, let's do that. I just want you to interpret that. What do you think, Ayun?
The greatest point where the rate coming in.
You're getting too technical for me again. I just want like a straight up translation, like really basic translation. The most water in the tank. What's another word we're really familiar with? Maximum. Okay, so let's be careful with this. We want to maximize what? The amount of water. There you go. I want to maximize the amount of water.
Which is also the maximum difference.
True. Maximum difference between the amount that came in and the amount that went out, right? Yeah. Okay, so we're going to try to maximize the amount of water. And Anna, the reason why I say that is because the things on the graph are actually rates. So we want to be careful what we're trying to find the difference between. Okay, so if I'm trying to maximize the amount of water, I need to set amount of water prime. In other words, the rate of change of the amount of water equal to 0 or dNE. Then we'll use the first or second derivative test. So where is my equation for the amount of water?
Is it?
Well, be careful with that because f of t and g of t are rates of change of the water. So I'm looking for an equation for the amount of water. Do you see it anywhere?
No.
It mentions it, right? It says the amount is modeled by, it's the very first sentence. The amount is modeled by a continuous function, but then it goes on to tell you like almost nothing about it, right? So we kind of hinted at this last time. Maybe we should do it this way just for fun. Is it okay if we say A of t stands for the amount of water? I'm just going to make up our own function and say, hey, this stands for the amount of water. So if A of t stands for the amount of water, and we're trying to maximize the amount of water, I have to set A prime equal to 0 / dNE. What on earth would A prime, like I don't know what A of t is. Do I have any clue what A prime is? There it is. This is that net rate idea. A prime is equal to f of t minus g of t. Let me ask you a crucial question. Why is it A prime, but then it's just f of t and g of t with no primes over there? Because why? Those are, and let's be really specific. They are rates, but aren't those already the rates of change of the amount of water? They're the derivatives of the amount of water, right? You're exactly right. So that's why that's the way that it is. So again, following our instructions up there, we need to set A prime equal to 0 / dNE. Okay, so this would definitely be a calculator active question again. How on earth am I supposed to figure out, let's do the dNE first. Do you guys see any places where A prime just would not exist? 3. Yeah, that's exactly right. You see the double open there. So that would be t equals 3. And then we also want to consider where f of t minus g of t equals 0. On the graph, what would that be represented by? Say again? Intersection points, yep. So perhaps on your calculator, you'd want to do this. Find those two intersection points. Take the time to do it. We got about 8 minutes here. I think this would be good practice. You definitely need to know how to find intersection points and zeros and those kinds of things. So please do try that. Let me know if you're struggling at all. And you guys are right. It's like roughly 1.5 and roughly 5. You could put both of them in. There actually is a way to do a domain, which I forgot. But you could just do it that way. You can actually do a domain and make it like stop. Well, you know what? I don't remember either, so I couldn't even help you right now. But there is a way to do it. You got to use like the little programming language thing, and there's. Yeah, there was one time we were doing something like this, and we had a little extra time. We're like, hey, let's Google it. So we Googled it, and sure enough, there's a way to do it. Cool. So does anybody have that first one that's roughly 1.5? If I were you, I'd be making my window go from 0 to 7 and 0 to 2,500. I would try to make my window look just like that. 1.617? Okay. And there's just that last one, t equals roughly 5. Anybody have that one? Yeah, needs to speed up. Come on. You got 5 point something?
5 point, wait, what? Oh, 5.076.
Guys okay with that? 5.076. For that upper one? Pretty sure it's 5 something.
I got 5.076.
Okay.
Oh, wait, so that first one?
For the first one, we got 1.617. Okay. Got those two okay? Good on those procedures? Okay. Oh, check the mode. No, she's in radians. Go back to your, let me just run through it real quick. For the first one you said?
Yes.
In calc. Oh, you just traced it, didn't you?
Yeah.
Don't do it.
Okay.
So we're going to go second calc, intersect.
Oh, no, that's what I did.
First curve, second curve, guess. Let it think. Oh, why isn't it? Okay. Oh, wait a minute. You got 200, it should be 250.
Wow.
That should be a 250, not a 200. That's all it is. You know what you're doing. You just had the wrong number in there. All right. So, guys, I think we've kind of settled on these numbers as the right numbers for where A prime is either 0 or D and E. Are you guys okay with that? Mm-hmm. Okay. So then what we basically have here, I'll kind of do this in a similar way from last time. I've got 3 intervals. There's a green one there, and there's a gray one right here. And then I've got a red one over here. And then a yellow one over here. Okay, so if I'm looking for a maximum, I am looking for where A prime does what? Changes from positive to negative. So let's keep in mind that f of t is the curvy graph and g of t is the horizontal line graph. So I'm going to say something like I'm going to write a little more than I need to, but hopefully this will give you a sense here. At t equals 1.617, A prime changes from what to what? Let's think about that. So aren't I talking about on the left, I'm talking about the green interval? Do you all see how on the green interval the horizontal line is higher than the curve? And isn't our equation for A prime curve minus horizontal line? So it'd be something that's lower minus something that's higher, giving us a negative number. So A prime changes from negative to positive. Therefore, A has what? Yeah, so that's not what I want. So then I go to the gray region versus the red region. Okay, so here, in that gray region, I'm going to say at t equals 3, A prime changes from what to what? It is, yeah, from positive to negative. Again, our reasoning for that is on the gray region, you see how the curve is higher than the horizontal line? But on the red region, the horizontal line's higher than the curve. And so that difference of f of t minus g of t would change from positive to negative. Therefore, a of t has a relative max. And so that would actually be it right there. If we wanted to continue on and compare the red region with the yellow region, I think we'd see that a prime goes from negative to positive, kind of like on the first comparison, meaning that a would have a minimum there. Again, that's not what we're looking for. So I really wouldn't need this there at all. I would just need the statement there in the blue box. Yes, ma'am?
You have to say that it does not exist, or that a prime does not exist equals 0.
So that's a great question. I've already said that up here, like through this whole process.
So you don't.
If I hadn't already said that, I would have to say it.
Okay.
I just need to make sure that I'm saying that somewhere in my argument. Yeah. Any other questions?
So does that mean that in like practice you have the most water in the tank at
In this case, yes.
0.0001?
No, right at 3. Or yeah, like okay, yeah. So the instant after 3.
Okay.
Yeah, like 3, then a trillion zeros, and then a 1 or something. Sure. We're going to find that a question like this later on, we're going to have to start considering endpoints. On this one, we didn't really have to, based on the way all the numbers worked out. And we'll have to do some integrals to get there. We'll get there when we get there, though. So, let's see here. You guys have a website tonight. You're going to find some. Hey, listen, you'll find some unfamiliar-looking questions on the website. Like one of them I know is there are two unknown numbers, and their product is a maximum.
Oh, that.
Questions like that.
That's one.
Like, listen, it would be super tempting to be like, well, thanks, Mr. Anderson, we never covered this one. Really? Have we not covered maximums and minimums ad nauseum? It's there. You're going to have to figure out how to customize it for that situation. Like, for instance, what does the word product mean? Multiplication. So it's saying you have these two unknown numbers, maybe like x and y. Well, x times y would be our product, and we're going to try to maximize it or minimize it or whatever. It'll give you some other information you can use to substitute too. So you'll be tempted to say at times, what, we never did this. We did. I hope you guys have a great day, and I will see you on Wednesday.